series. What is series? Just take the sum. So I have a A1, A2 up to AK. Each of them taken one by one is called a sequence. If I take the sum, it's a series. I can have finite series. This K is smaller than infinity, or I can take limit K go to infinity. So this is called finite series and infinite series. And then what's partial sum? Partial sum means I have a series. That means I have to take a sum. But I just take part of it and then I make mistake. And then you know this from high school, arithmetic and geometric. Now here's the first time you see this ugly thing. This actually is called Taylor series. I define this as true. I'm not proving them they're true. You can prove them they are true by differentiation. At this moment, we assume we don't know what the heck is differentiation. So now I said I define this as true. I just look at the first two terms. It gives me some error. And I define the error as my first sequence. And then I take three term, I have my second sequence. And then I take four term, this is my first thing. I just need to prove that this guy converts to 0, then they are the same. So this is how you can define this, okay, using sequence. Later on, I'll tell you an easy trick to remember this three, but you need to remember this, okay? Convergence of series. So what is infinite series? It's just A1 plus A2 plus A3 plus A4 plus up to A infinity. What you're going to do? You just take their partial sum as a sequence. So that means what? You have a bunch of things. You add them together. This is my first guy. This is my second guy. This is my third guy. This is my fourth guy. You prove this guy converts to something, then this guy converts to something. This is exactly what I said, how I can say I know this is true. How do you prove 1 plus half plus 1/4 plus 1/8 plus go to infinity is 2? So I take the partial sum. That means what? That means this is my first A1. This is my A2. This is my A3. This is my A4. Now I have a sequence. Then what? You prove this guy converts. So this kind of thing you know, right? This is from high school. You have a starting point is 1 and the common ratio or common factor is half. So by sum of geometric sequence, you can know that you have this formula. That means for the partial sum up to n term, that means this is what? This is my an. I have a sum up to n term. It's just something like this. And then I said I prove this guy limit converts to L. That means I just take limit n go to infinity for this whole thing. Then 2 is constant, I take out. 1 is constant, I take out. Then I just need to take limit of this guy. This guy is just what? Go to 0. Therefore, this limit converge. So let me recap and talk about the whole picture. You have a series. That means a bunch of things added together. How do you prove this thing converge? You take the first part, this is the partial sum up to 1 term as your A1, and you take this, the partial sum up to 2 term, this is your A2. You take this is the partial sum up to A3, and you prove this thing is a bunch of dots. You prove this guy converges, then this guy converges. That's the idea. Here's a useful thing. If you have an infinite series, that means you sum from 1 to infinity. If this guy converges, then the thing inside has to go to 0. This is an example. I have a 1 here, and then suddenly I have a half, and then 1/4, and then 1/8. So in the end, I will add what? I will add 0. So basically it's saying that this guy getting smaller. In other words, I have a something like this. The sum convert to L is what? Thing inside go to 0. So this is the idea, okay? So how do you prove it? So I have this, right? So I can define partial sum, add up to the n term, then I can say this is my an, big N. So this converts to the limit s. So let's say this converts to s, this converts to s, then I have this. This means what? This means this guy go to infinity, which is just this guy. I said this guy converts, right? And I call it s. So this nothing new, okay? And what we want to do is prove that each of this guy alone converts to 0. Important. There's a sum here. This is one particular term. So they have different meaning. So what I'm going to do, I'm going to say that the nth term, what's the nth term? It's just the previous sum plus the last guy. I have an infinite sum. Now I take this bunch of things as my Sn, big N. This big chunk of thing is just this big chunk of thing, which is my Sn minus 1 plus my An, right? So I'm saying this. So green Sn is this plus this. Okay, if you have red green color blindness, then sorry. Then what? It converge. So I can put limit here. This guy limit S. This guy limit S. This guy limit unknown. Because we are saying we want to prove this guy limit go to 0, right? So I just keep this guy here. So I put a limit here. Give me this. I put a limit in a big bracket. Give me this. This guy is S. This particular guy is also S. Limit of this guy is unknown. We don't know. But now we can see S equal S plus something. So of course this guy limit is N. And here's a trick. It doesn't matter. I call this N, right? I can call this apple. I can call this chicken. I can call this dog. So I can call this N. It's saying that if I have something sum to infinity and it gives me a limit, that means not infinity, some number, the thing inside will go to 0. But the converse is not true. This guy, the thing inside go to 0, but this guy sum go to infinity. So this is why you need to pay attention and why you need to understand all the equal sign. Because if you somehow think that, oh, this is trivial, this kind of thing come back to bite you. And then this one is additional reading. We come back to this after we talking about integration.